are studying the other very important chemical property for our mild steel known as the carbon equivalent. Now, before I start explaining to this carbon equivalent, it is represented by CEQ. This carbon equivalent actually gives us one proof that only single carbon is not responsible for some properties of steel. But there are some other elements combined with carbon to form the allying characteristics. Which allying characteristics mean change in certain properties of steel. So when those elements, let me tell you, those allying elements when it's combined with carbon, they form carbon equivalent. Let me tell you which are those elements and how they are going to combine with the carbon. Its solution is like CEQ. It is a carbon. It is one element. Then it is another element. You see, in this equation, C is for carbon, Mn for manganese, Cr for chromium, V for vanadium, and this Mo for like you can say this vanadium. Mo is for molybdenum metal, and Ni for nickel, and Cu is for copper. When these values are combined, you see this one, when these values are combined with the carbon, the equation developed is known as the carbon equivalent. Let me tell you, when these elements are combined with the carbon, whatsoever their value come, then the equation developed is known as the carbon equivalent. As per standard BS 4449, its value is also mentioned. Like its cost value should be 0.50 and product value should be 0.55. If this value is being violated, then our material is going to change its characteristics. Now let me tell you, as all the, if we have this chemical report with us, in this report, when we are studying the values of certain elements, like as we have done over here earlier, value of C is equal to 0.18, value of manganese is equal to 0.63, and these are value given over here. And next, this value of chromium, it is equal to 0.01, And then value of vanadium is also 0.01. Then other value, for this value of nickel is equal to 0.02. And next, the value of MO is given in this report as 0.05. When all these values are put in this equation, what we get? CEQ 0.18 plus 0.63 divided by 6 plus 0.01, 0.01 plus 0.05 divided by 5 plus 0.02 plus 0.04 divided by 15. The value of Cu, copper, is equal to 0.04. It is given over here. When these values are taken from the test report and after making the calculation, we reach to the conclusion that value of CEQ comes out to be 0.03. 0.30. So CEQ is equal to 0.30. If we see this value, it is less than the specification limit 0.50 to 0.52. This is our value as per BS 4449. Here I would like to tell you one thing. Suppose if value become greater than the specified value, what will happen? The characteristics of steel will change. Which are those characteristics which are going to be changed? First of all, it will not be low carbon because carbon amount has increased. If it will not be low carbon, it is going to get brittleness. One very important property, it is going to get brittleness. Second, reduction in weldability. Third one, hardening. So this steel is going to get hardened. So these are the property which are not required for hardening, for mild steel. Because mild steel should not go to the brittleness. Mild steel should have the property of weldability. It should not show the behavior of hardening. So that is why, in order to get the steel to be true grade means it should be B500B. It should satisfy this combined chemical property and its individual chemical property. If these values, when the test report is coming in front of you, you will have to check these properties, that these properties are complying to our specification or not. If they are violating our specification, so it means it is not acceptable. So we will have to see this value, that these values are exactly according to our standard. Then we can say that our steel has satisfied the chemical composition requirement and it is well within the requirement and we can use it as reinforcement bar. Thank you very much for seeing.